Hello students. Now I will discuss you how to find capacitance of a capacitor. So let me write the capacitance. Capacitance is ability to measure the capacity of a capacitor. Means how much energy stored in a capacitor, that measures its capacitance. So let us go with very basic the capacitor, that is parallel plate capacitors, and I will tell you what will be its capacitance. Suppose this is a parallel plate capacitor. Two plates, generally their area is much larger compared to the distance between the plate. If I compare the area, means I mean to say their linear dimension, length and breadth, is large compared to the distance between the plate. Let the distance between the plate is D and area of each plate is A. And let this capacitor is, I named this capacitor to be A and this capacitor to be B. This is the area. Area is A. Alright, so what I mean to say, that if I take a plus Q charge from plate B and given to A, because as I said you in the last lecture, in the capacitance is defined as charge on one of the plate which is taken from the another plate. So you think now onwards the charge on the positive plate. Let the charge on positive plate is plus Q and the potential difference between the plates is VA minus VB. That is the potential of higher potential minus lower potential. So you know that is the plate A having the positive charge and this will having the negative charge, then definitely it will have higher potential and this will have lower potential. So the capacitance of a capacitor we can measure by the charge on positive plate divided by the potential difference. So what we do, we take the charge from plate B, both plates are initially neutral. We take the charge from plate B and give it to charge A. How we do that we will study later. But if we do this, so what will happen? There will be potential difference set up between the plates. So let me draw the vertical diagram here in side view. This is two plates. Let the plate A and B, and the charge here is plus Q and this will be minus Q. You know that the charge will come on the facing surface only. That from the Gauss law. And if you want to know this thing in detail, please go to my lectures of Gauss law. You will get all these things. Why the charges are on the facing surface when charges are equal and opposite on two capacitors. It means two plates. Sorry. So this side the charge is 0 and 0. And if you see the electric field between the plate, it will be uniform and E is equal to sigma upon epsilon naught, where sigma is Q by surface area. That is the charge density. So this is the electric field that you know very well. If you from Gauss law, already I discussed those things. If you draw a Gauss law like this, and here the electric field, you can write from this E dot ds is equal to Q upon epsilon naught. So if I take all the surface, this electric field is angle is 90 degrees, so 0 for annular surface. For inside surface, the electric field is 0 inside a conductor. Only for outside surface it is left. So it will be E ds is equal to Q is what? Sigma ds upon epsilon naught. If I take integral, then it will be E delta S. So delta S is out, so E is equal to sigma upon epsilon naught, that you can understand. Anyway, you go in details to my lecture of Gauss law, so you will understand all these things. So E is this, and then the potential difference, that is if we go in direction of electric field, then potential decreases. So VA minus VB, for uniform field it will be electric field into distance. The distance is D, so E into D. So VA minus VB is equal to sigma D upon epsilon naught. Then if you go to the next page, let me go to the next page, and I can write C is equal to Q upon VA minus VB. So Q upon VA minus VB. So it will be VA minus VB is what? E into D. E is what? Sigma upon epsilon naught into D. Sigma is what? Q by A epsilon naught D. So if I find the capacitance of two plates parallel to each other, generally their linear dimension, length and breadth, is 6 times minimum, between the distance between the plates. Then only there will be less fringing effect, and you can able to find the capacitance perfectly. That I will discuss even later. So let me find first the capacitance. So here Q upon QD by E epsilon naught, so it will go up. So we got the capacitance is epsilon naught A upon D. So what we could find, the capacitance of a parallel plate capacitor. This capacitor is known as parallel plate capacitor because two plates are parallel to each other. So what we got, for parallel plate capacitor, the C is equal to epsilon naught A by D. So it depends on the area, it depends on the distance between the plates, and also it depends on orientation and all. But here I have taken parallel plates, so plates are facing surfaces are parallel to each other. So what we can see, the capacitance depends on dimension. So depends on dimension, that is area, distance between the plates, and it also depends on epsilon naught. Epsilon naught is the permittivity of the free space. If we consider this is a free space, you can think vacuum, not possible. So we can think also air, hardly 0.06% difference if I consider air in place of vacuum while finding the capacitance. The epsilon naught value is changes very small. The value of epsilon naught will be C D upon A, you can say, and if I write like this, and it is a constant, its unit I will tell you, it will be farad, and D upon A, so meter upon meter square, farad per meter, and this you can, its value is 8.85 10 raised to minus 12 farad. So the value of capacitance is 8.85 10 raised to minus 12 farad per meter. So this is the SI unit of epsilon naught. So I will discuss you more about the parallel plate capacitor. We will discuss you about the energy also, where the energy is stored, how the energy is stored, and how much energy is stored. All these things we will discuss in next lecture. Thank you.